So one of the things I'm wanting you to get out of this class is to get a sense for, as we're talking about the nebular theory, the formation of our solar system, the sun and the planets, I want you to get a sense of timing. And also kind of want you to put that in perspective when we ultimately talk about timing of the creation of the universe. Via the Big Bang, of course. So you're like, well, how do we know how old our solar system is? And one of the things is we can check on space rocks. And so here's kind of we'll be talking more about meteorites, but just to kind of give you a quick and dirty so we're all on the same page. This is Earth, not drawn to scale, and this is the Earth's atmosphere. Should make dashed lines. And then this is beyond Earth's atmosphere. And there are times when, because of an assortment of reasons, basically, there's a space rock that is going to fall through the Earth's atmosphere. So while it's out here, if it's of the right size, not necessarily an asteroid, but a chunk out here we would call a meteoroid. Meteoroid. Okay, space rock. Okay. Now, if it falls through the Earth's atmosphere, it can create that streak of light we call a falling star. Okay, this was my streak of light. So it doesn't last very long, and that is actually a meteor streak. Okay, goodness. There we go. So they don't last very long. If there's anything substantial to pick up, or even if there isn't, they're actually micrometeorites too. But if you can pick up the rock that made it through Earth's atmosphere is a meteorite. Okay, meteorite. Okay, I don't know. Meteorite, I know that for sure. Okay, so the thing that you pick up. So these are space rocks. And so basically what they've done is how we identify them as being a meteorite. I'll kind of talk a little bit later. But basically they assay it and they understand that its composition is not consistent with being from the Earth. So it's a space rock. Okay, so space rocks can be dated then. Now, we don't use carbon-14 techniques to date meteorites because carbon-14 works for things that were once alive. But what we can do, and I know this is a busy slide, is to look at the amount of one form of potassium with a mass number of 40. Let's see, where is this? So potassium is an element. Of course, the symbol for potassium is K, right? And potassium will decay into argon, okay, over time, and the rate of decay to form argon is well known. So basically these space rocks, all we got to do is check the ratio of potassium left to argon that's created. Okay, so there you go. So talking some dates, there's actually 3 types of meteorites, okay, that make it through Earth's atmosphere and we can pick up in general. So dating-wise, using the isotopes of potassium to argon, we're looking at rocks being about 4.6 billion years old. So that basically is the time at which the sun began burning, which the sun began nuclear fusion in its core. So that dates the solar system. Okay, so 4.6 to 4.5, that ballpark. So I want you to remember